Welcome to this session. In this session, we have a problem to transform a matrix into a unit matrix by elementary operations. So this is how we solve this. Solution. So A matrix is given by 1, 3, 3, 2, 4, 10, 3, 8, 4. Now remember this being a 3 by 3 matrix, so the objective is to transform this one into 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is what is the unit matrix. That we need to transform this given matrix into. Now, 1, 3, 3, 2, 4, 10, 3, 8, 4. This is a matrix A. Already this element is 1, so that one we are okay. This position we are okay because it should be 1. But this should be 0, this must be 0. So I'll say row 1 to remain to be row 1, and then row 2 to be row 2 plus. Now I need to multiply this one by -2 so that when I add to 2, I get 0. So -2 row 1. And then row 3 should be this value. You need to multiply this one by -3 so that you get 0 here. So by doing that, we'll get the matrix. A is now equivalent to 1, 3, 3, and this will be 0, 4 plus -2 times 3 is -2, 10 plus -2 times 3 is 4. This is 0. 8 plus -3 times 3 is -1. And then 4 plus -3 times 3 is -5. That is step 1. As step 2, we can make this one to be 1 by simply multiplying all of this row by -1/2. So you say row 1 to remain to be row 1, row 2 to be -1/2, row 2, and then let's keep row 3 to be row 3 in this step. So that will give us A will now be equivalent to the matrix 1, 3, 3, 0, 1. So this would be now -2, 0, -1, -5. That's what we'll have. Now we need this to be 0. So we say let row 1 to be row 1, row 2 to be row 2, and now row 3 to be row 3 plus row 2. Because when you add 1 to -1, you get 0. So this will transform A into an equivalent matrix of 1, 3, 3, 0, 1, -2, 0, 0. Adding these two, we get -7. Now, so remember we can make this one to be 1 by dividing or by multiplying, simply by multiplying by negative 1 over negative 7. So row 1 to be row 1, row 2 to be row 2, row 3 we say to be negative 1 over 7, row 3. So this will transform A into 1, 3, 3, 0, 1, minus 2, 0, 0, 1. So far this one is in echelon, row echelon form. This is in row echelon form. Now we expect this position to be 0, this one to be 0, this one to be 0. Now, if I say now, row 1, if I say now, next step will be row 1 to be row 1 plus minus 3, row 3, and then I say row 2 to be row 2 plus now 2, row 1, and then I say row 3 to be row 3. So it's like now I'm reversing back my processes. So that will transform A into, now when you say 3, so this 1 plus minus 3 times 0, I get 1. 3 plus minus 3 times 0, I get 3. 3 plus minus 3 times 1, I get 0. 0 plus 2 times 0, I get 0. 1 plus 2 times, this is 3. I get 1 minus 2 plus 2 times 1 is 0. This is 0, 0, 1. So that's what we have. Now, so the next step is to ensure that this position is 0. So I say row 1 to be now, because I've already used this row 3, I say row 1 plus minus 3, row 2. Row 2, I keep it, row 2. Row 3, I keep it, row 3. This will give me A is equivalent to, now 1 plus minus 3 times 0 is 1. 3 plus minus 3 times 1 is 0. 0 plus minus 3 times 0 is 0. Now this is 0, 1, 0, 0, 0, 1. And this is what we wanted to prove, or we wanted to confirm. So this is the final solution. Thank you.